Yes. Yes. So, with number 7, we have a conditional statement. A conditional statement is an if-then statement. In this case, it's if I jump out a window, then I will land in the grass. And what we do is we take this whole I jump out a window part and replace it with the J. If J. So this is if, and then J. Then is your arrow. So you always want to use this arrow as a then, and you always want to use this 3 lines as a if. Next, we want to take this whole part, I will land in the grass, and replace it with just one letter, or one symbol, right? In this case, L. And that becomes your conditional statement. Your converse statement is when you take that statement and you make a mirror image of it. So you say the last first and the first part last. If I land in the grass, then I jumped out the window. That would be your converse statement. Right? Now, your inverse statement is going to be when you take your conditional statement and you put nots on both of them. If I do not jump out the window, then I will not land in the grass. Okay? And then your contrapositive is when you have your converse statement and you have nots on both of those. So, if I do not jump in the grass, or if I do not land in the grass, then I did not jump out the window. Okay? The problem with these is that a lot of these if-then statements have counterexamples. In other words, they're not true, right? You can give a counterexample for, if I jump out a window, then I will land in the grass. Not true. I could land in water, right? So, if I jumped out of a window of a car, I might land on a bridge. You just don't, it's just not true. Not always true. Sometimes it would be true.
Another person.
Or another person. But it's not always true. And so none of these cases will probably not always be true. Okay? Yet when you get into mathematics, you'll find that if a case is true in one spot, it'll be true all the way through. And so when you look at this, if 2 lines intersect, okay, so if 2 lines intersect, they are not parallel. Well, that makes sense, because to be parallel, they can't intersect, right? So if 2 lines intersect, then they are not parallel. Okay, that works. Then we look at its converse. Okay, if they are not parallel, they're not parallel, then they intersect. Okay, that works, right? Then we look at the inverse, and the inverse is actually going to have a knot here, right? Because where this doesn't have a knot, will have a knot, and where this has a knot, it won't have a knot. Okay? So, in this case, you're going to have, in this inverse, you're going to have, if they do not intersect, so they don't intersect, okay, they're not intersecting, then they're parallel. Oh, that's true. You see that? And then, in this case, we're going to take this one, and where they have a knot, we're going to take it away. So the converse is going to have the knot part taken away, but where it doesn't have a knot, we're going to add one. And then we'll restate it. If they're parallel, then they do not intersect. Well, that's true, right? So it was true all the way across the board, whether the conditional statement, the converse statement, the inverse statement, or in this case, the contrapositive. Contrapositive statement is true. And that's problems number 7 and 8.